everyone. So today we're going to talk about L'Hopital's rule, and more specifically we're going to talk about L'Hopital's rule with infinity. But before we get started with that, let's just talk about what these limits are here in parts A, B, C, D, and E by looking at the general shape of the graphs of these functions. Alright, so we looked at the general shape of the graph of polynomial and power functions back in Unit 1 to figure out what the limits of those functions were as x approaches infinity or negative infinity. So now I'm just adding on an extra layer. So I'm adding on the limit as x approaches infinity or negative infinity of exponential functions and then logarithmic functions. What you're going to mostly see in calculus is the limit as x approaches infinity of e to the x and ln of x, because e and ln are just so natural for us mathematicians. But you could also see 2 to the x or log base 2 of x, and the ideas that I'm teaching you with e to the x and the natural log also apply to the exponential function 2 to the x or the log function with a different base other than e. Okay. So let's look at the graph of e to the x. Well, I'm just going to draw a general shape of this graph. Okay, so the general shape of this graph looks something like this. Okay. And so this is true actually for what's called exponential growth functions. And so all that means is if you have a number raised to the x variable and your base, your number that's being raised to the x variable is bigger than 1, the general shape looks something like I just drew under part A right here. Okay, so since e is a number that's bigger than 1, the general shape of this graph is going to look something like this. Sorry, I'll draw it honestly a little bit better. You don't have to change yours, but I'm just being picky at this point. Okay. And so since in part B we're looking at the exact same function, I'm just going to draw this again. So this is x, this is f of x, and then here is my graph. Okay. So, looking at this graph, I want to figure out the limit as x approaches infinity of the function. So what's happening as x is getting bigger, right? When I read x approaching infinity, that's what I'm thinking to myself. What's happening as the x values are getting bigger? Well, my output values or my y values, they're also getting bigger, right? Because the graph is pointed upwards. And so here I would say that the limit is infinity. Okay. What about in part B? Well, what's happening as x is approaching negative infinity? So now I'm looking to the left of the graph because I want to look at what's happening when my x values are getting smaller. In other words, they're approaching negative infinity, right? They're getting more and more negative. What's happening to my output values? Well, here I see that the y values or the output values are approaching 0. Okay, because you notice here that towards the left, the graph is getting closer and closer to the x-axis, right? So I want to know what's happening to the y values if it's approaching the x-axis. Well, the y values on the x-axis is 0, and so here I would say that I'm approaching 0. Okay. Now I want to draw the general shape of e to the negative x. So e to the negative x is what we call an exponential decaying function. So the general shape for this graph looks something like this. Okay, and since we're also exploring it in part D, I'll just use the same thing, the same graph here. So this is x, f of x, x, f of x, and then here's my general shape. Okay. So now I want to know what's happening as x is getting bigger. What's happening to the graph of my function? Well, the graph is approaching the x-axis, right? So as x is getting bigger, my output values or my y values are approaching 0. Okay. What about the limit as x approaches negative infinity? So now I'm looking to the left of the graph. And so as x is getting smaller, it's going towards negative infinity. I see that my output values are pointed upward. And so I'm going towards infinity here. Okay, and so last but not least, I want to know the general shape of my natural log function. Okay, so this is the general shape of my natural log function. It looks something like this. Okay, and so what's happening as x is getting bigger? What's happening to my output values or my function values? Well, they're also getting bigger, and so therefore the limit as x approaches infinity of ln of x is equal to infinity. Okay, and so at the bottom here, I just tell you to refer back to our Unit 1 notes for limits with infinity of power and polynomial functions. All right, because now all of this stuff is going to come together so that we can figure out what's happening for the limits below when we start talking about L'Hopital's rule.